Okay, so now we're moving on. So you guys should have been done with your first exam. Hopefully that went well. So now let's move on to actually talking about bones. So let me give you an intro to this module first. This module actually has the most information. Okay, so you probably need the most time studying. It's not particularly difficult in terms of the type of information that I'm giving you, but it's the most amount of information that I'm giving you. So be prepared, okay? So, start making flashcards, um, set aside more time to study, study with people, okay? Watch the videos a couple of times, okay? That in particular regarding bones and muscles always helps, okay? And actually, one of the things I like to try and get you guys to do is exercise. When you exercise and you actually do these exercises, use these muscles that we're talking about when we talk about muscles, it actually trains muscle memory, okay? You remember, like, you connect things you do with actual information, and that actually helps a lot. Okay. That being said, let's start on chapter number 6. Okay. Screen. Okay. So chapter 6. Okay. So cartilage. Okay. The basic structure of cartilage you already know, right? So location and basic structure of cartilage. Cartilage is found throughout the body. There is, and you see the model here, okay? The light blue is hyaline cartilage. The green is, let's see what the green is. The green is elastic cartilage, and the red is fibrocartilage. So make sure you understand where all these 3 different types of cartilage are located and the differences in how they're used. Okay, so all cartilage consists of something called perichondrium. Okay, so like we talked about earlier, cartilage has no blood supply. So the blood supply actually has to come, the nutrients has to come from the perichondrium in. Okay, so it functions in the growth or repair of cartilage. Okay. It consists primarily of water. Okay, cartilage is primarily water. It's about 80% water, and it's resilient, so it springs back to original shape. Okay, after you compress it. Okay. Okay. So all cartilages have something called a chondrocyte. The chondrocyte are located within the lacuna, and you can see the 3 different types of cartilage here. Okay. Okay. So positional growth and interstitial growth. Okay. Positional growth is the chondroblasts in the perichondrium producing new cartilage. So let me show you how that works. I show a new video. Okay. So here's my piece of cartilage. Okay. Here, okay, is a perichondrium. The perichondrium will generate new pieces of cartilage here. Okay, so the newest cartilage will always be on the outside. Okay, and that is apositional growth. Interstitial growth will draw a circle. Okay, so there's my piece of cartilage. inside of my piece of cartilage is a chondrocyte. That chondrocyte will divide in two. And what will happen is these two will grow new matrix. Okay, so this one will grow more matrix, so it will move further. And that one will push further apart. And because of this, this piece of cartilage will get bigger. Okay, interstitial growth, growth from inside. Okay. Okay, so this chapter is primarily about bone and how bones are formed. Okay, bones contain several types of tissue. Okay, but they're dominated by the bone connective tissue that we saw. Okay, but bone, unlike cartilage, has nervous tissue and has blood. Okay, and has cartilage on the edges. Okay. Okay, the function of bone. Bone provides support, okay, provides movement, provides protection, okay, so, your skull, right, your chest cavity, okay, it provides mineral storage. It's a very important reservoir for important minerals, especially calcium and phosphorus, okay. It's involved in blood cell formation, so the bone marrow, right? I'm sure you guys heard bone marrow before. Bone marrow is found within bone, and bone marrow is responsible for formation of red blood cells and white blood cells. Okay. All right. Bone is made out of two things. Okay. So bone is the only kind of tissue that is made out of a large percentage of inorganic components. Okay, so bone has the organic components, the cells, the fibers, the ground substance that you're very familiar with from every other tissue. What makes bone different is that it has a large amount of inorganic components, salts. Okay, they invade the bone matrix and make the bone matrix stiff and hard. Okay, that's why bone is so hard. Okay. Okay, so bone has exceptional qualities. 35% is organic. Okay, organic components contribute to flexibility. Okay, it makes bone slightly bendable. So if you try to look at bone, get a bone off like a raw chicken or like raw cow, but not like cooked stuff. Okay, the raw stuff is slightly bendable. It's like, put some pressure on the drumstick, it'll bend a little bit before it breaks. That is the organic component of it. Okay, it contributes to flexibility and tensile strength. The inorganic components, okay, provide exceptional hardness and resist compression. Okay, so let's take this apart. So what would happen to bone if you didn't have the inorganic components, the calcium? Okay, the bone will become soft. And I'll forward to the end of the chapter and I'll show you the picture of what happens if you don't have enough calcium. And I'm sure you guys have probably seen this before. It's rickets. Okay. The other thing that happens is the disease where you don't have the organic components. Okay, when you don't have the organic components, okay, when you don't have the organic components, what happens is the bone becomes too stiff. It becomes brittle. it's like porcelain, right? It's hard, but it breaks easily. And that's what happens when you don't have the inorganic components. Okay? Or sorry, when you don't have the organic components, you have the stiffness of the inorganic components, but now it's brittle. And that disease is called osteogenesis imperfecta. Okay? And you die of it either in like late in utero or early after childbirth. Okay? And don't survive for more than 1 or 2 years. Again, horrible thing to go through. Okay. There are 3 types of cells that help make bone. Okay? They're called osteogenic cells, osteoblasts, and osteocytes. Osteogenic cells are stem cells, okay, that are going to be osteogenerating. Okay, so genic, generate. So these are going to eventually form bone. These are stem cells that eventually develop into osteoblasts. Okay. Okay. Osteoblasts, okay, are going to actively secrete osteoid. Osteoid is the gooey stuff that the osteoblasts secrete. Once the osteoid is secreted, it will harden, and when it hardens, it turns into solid bone. Okay, so osteoblasts will secrete osteoid. Once the osteoid is formed around the osteoblast can't do anything anymore, and it turns into an osteocyte. Okay. The last type of cells that are found in bone are called osteoclasts. Osteoclasts are found within bone tissue. Okay, they're usually on the inner edge and the outer edge of the bone, and they're responsible for reabsorption of the bone. Okay, they absorb bone. So one of the things you realize, and we'll talk through, is if you don't exercise, you lose bone very quickly. Okay, you might think like, because a lot of people think bone is like solid and never changing and it's dead material, etc. Because you're used to seeing like picturing skeletons. Inside the human body, your bone changes all the time. Okay, if you put on muscle, you put on bone. If you lose muscle, you lose bone. Okay, so putting on bone is going to be these 3. Taking away bone is going to be osteoclasts. Okay. Okay. Classification of bones. Bones are classified based on their shape. Okay, so like if you picture a cartoon of a bone, that's a long bone. Okay, long bones are longer than they are wide, and usually not even close. Okay, short bones are going to be bones in the wrists, okay, or in the ankles. Okay, so they're going to be like kind of squarish. They're as long as they are wide. Okay, and then flat bones are flat. Okay, like your sternum being an example. Okay, your skull being another example. Okay, all the bones in the skull are more or less flat bones. Okay, and then you have irregular bones. Irregular bones don't fit any of the other 4 categories. Okay, so your vertebrae, your hips, okay, are all flat bones. Or sorry, irregular bones. Okay. So bone, okay, is used for protection, okay, and therefore it has to be hard. But the other problem that people don't realize is bone has to be relatively light. You don't want to be walking around with 50 extra pounds of bone that you don't have to carry around. Okay, that makes you slow. right? And that makes it harder to run away from lions and tigers. Okay, so what you want is a combination of good protection and being light. And so the way they deal with this oops, sorry about that. Okay, is to make a hollow circle. Okay, the thick red line is going to be compact bone. Compact bone is extremely dense. Okay, spongy, and then you're going to have spongy bone on the inside. Spongy bone is literally little tiny lines of bone. And it looks like sponge, okay? That makes it hollow, but strong, okay? Let me show you how that looks like. Okay. So, compact bone, spongy bone, okay? Compact bone, spongy bone, okay? Okay, we're going to talk about the structure of a typical long bone. That's one of the things you have to label, okay? So the diaphysis is the shaft of the bone, okay? The epiphysis are the ends of the bone. In that bone labeling, you guys have something in the middle called the metaphysis. Don't worry about labeling that, okay? Some books divide parts of the bone in three, or the middle section, and some don't. Okay, it's just part of the epiphysis. Okay, so just diaphysis and epiphysis. Okay, the bone is very well vascularized. There's a lot of blood that goes to the bone. Okay, and in the middle of the bone, there is a medullary cavity that's filled with either red marrow or yellow marrow. In adults, that marrow is yellow. It's basically fat. In children and especially in babies, that is red marrow and actively making red blood cells. Okay. There is a membrane. Okay, there's two membranes that surround bone. Okay, let's talk about those two membranes. Okay, so there's a membrane on the outside of the bone, and that membrane on the outside is called periosteum. Peri means around, perimeter, right? Around osteum bone. Okay, on the inside, you have another membrane, okay? And that's called the endosteum. Endo, inside. Osteum, bone. So endosteum, okay? All right, back to lecture. Okay. We'll skip the structure of short bones, okay? So bone design and stress. The anatomy of bone reflects stress, okay? So here, okay, you can see how the stress changes. Your load comes down on this is your femur, this is your thigh bone, the weight of your body comes down right on the head of the femur. And you can see that if you push down this way, this area will become compressed and that area will be kind of bent out, okay? There'll be pulling on that side and compression on this side. right in the middle, right in the between that, the forces all cancel out perfectly. And that means you have no force there. That means you have no stress there. Okay? And if you look, there's no bone there where there's no stress. You don't need bone if there's no stress. Okay, the bone markings we'll skip for now. You can review these by yourselves, okay? And we'll talk more about these things when we talk about these on the bones themselves. Like, you need to know what a tuberosity is, because we'll ask you what the tuberosity is, what the humeral tuberosity is, etc., etc., etc. Okay. 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 So you guys can go through this by yourselves later. Okay. The next thing I'm gonna go over is the microscopic structure of compact bone. Okay. That's the other model that you guys have to really understand. Okay. So let's talk about compact bone. Okay. Just because the compact bone is compact doesn't mean that there's no blood. In fact, there's special passageways for blood vessels, nerves, lymphatic vessels, etc. Okay. First of all, the osteon is the functional unit of compact bone. Okay. So when we build compact bone, we are building osteons. When we tear apart compact bone, we're tearing apart osteons. Okay. Okay. And these are the three ring structures you saw in the tissue chapter. Okay. Okay. Osteon consists of lamellae, the central canal, the perforating canal, and canonically. Okay. So let's talk about the osteon. Okay. So this whole structure is a osteon. Okay. This whole structure is a osteon. A osteon is also called a haversian system. Okay. In the middle of an osteon is a hole. That hole is where the blood vessels run. Okay. That hole is where the nerves, arteries, and blood vessels run, and that hole will always be parallel to the length of the long bone. Okay, so that is the central canal. See how it runs right along the length of the long bone. But the central canals have to talk to one another. So there has to be channels that connect central canals. And those are called perforating canals. Okay, because they perforate through the osteon. Okay, and so they're called perforating canals, or the other name that most people use actually, they're called Volkmann's canals. Okay, named after Volkmann, who discovered them. Okay, now let's go back to the osteon. Okay, the osteon is made out of these concentric circles of solid bone. The concentric circles of solid bone are called lamellae. Okay? So each one of these are called lamellae. Okay? They're also called concentric lamellae because they run in concentric circles. Okay? You also have solid bone that run all the way around the edge of the long bone. Okay? Those lamellae are called circumferential lamellae because they run around the circumference of the bone. Okay? All right. Now let's take a closer look at the lamellae here. The lamellae have little lacuna, okay, little lakes. Inside the little lakes is a osteocyte. Okay, the two lacunas, two little osteocytes have to be able to communicate with one another. So they'll literally dig a channel through the bone to the point where they touch. And that little channel through which they touch is called a canaliculi. Okay, those are canaliculi or canaliculus. Okay, canaliculi literally means small little canal. Okay, all right. You probably want to replay this part at least once because you do have to know like all the parts of the osteon. So make sure you do that. Okay, moving on. Okay. So bone has collagen fibers embedded in the lamellae. And the reason why the lamellae run in concentric circles as one solid piece is because this way you have the collagen fibers run in different directions. When you have the fibers run in different directions, it is very hard to untwist them. If they all run the same direction, you can just go between it. You can just twist the same way and you'll untwist them. This way, because they run different directions, there's no way to untwist. Okay. Okay, we'll skip the spongy bone. Okay, and we will stop right here and we'll pick up the part 2 on part 2 of the presentation.